Okay, let me get my chats working. Dun, dun, dun. Cool, got that one working. I can't find the other one though. My vertical should be working. Test chat. That works. Cool. Good. Sometimes I gotta mess with this. One sec. Let me. Reset this. Turn off YouTube vertical settings. Yes, reset. Cool. Copy. All right, there we go. What's up, sibling? Oh, I think this is working now. It says we're live. That's great. Oh, it says we're... No, it should be a different one. That's upcoming. What's up, Nasser? Need my social stream to work. Come on. Come on, social stream. What's up, Sensation?
What's going on?
Did you enjoy all the confusing calculus I was doing earlier today?
I was outside stunning guard and I was just like, I'll try and watch this at the same time.
Oh, man. Yeah, that's kind of crazy, wasn't it?
I can't see anything.
Yeah, let me try. Let me see here. They updated OBS, which I'm like scared. Scared to see what happens.
You have been disconnected. Oh, there we go.
There you go. Is that working now?
Yep.
Can you see the
fine,
stream? Yeah. You can see it? Okay, good. Yeah, they did an update on OBS, and I always get worried when they do updates to see like what breaks. Yeah, it looks like. Oh yeah, look, yeah, that's my web browser on the top there isn't connecting to Discord anymore. See, they change things. How rude. Nasser says, I had a question. When the grades would come out? Soon. It's next year. No. I was just going through, they took a midterm on Friday, and I was just going through grading it. I think probably by either end of tonight or early tomorrow. I want to get the solutions kind of written up and finalized from Albert, our TA, before I just start letting grades out, because then people are going to start being like, well, wait a minute, what's the right answer? So I want to get a solutions manual first. So let me email Albert and see where he's at with that. And then we'll probably have grades out either, yeah, late tonight. Yeah, do you see that? Do you see how that's missing? Do you see that? That thing's missing on the top there. Sensation, yeah? Fucking OBS, dude. How is the grading going? Grading's good. I mean, I have like preliminary grades already ready. Yeah. Oh, see, now it's working, and this is a short. Activate that. There we go. What's up, Octavio? Is it better than the first? Yes. Yeah, the average on this one, I think, is like an 87. Compared to, I think the average on the first exam was like an 80. And then the median's super high. The median's like a 92. I gotta go like double check. There are like a lot of suspicious 100s on this exam. I'm like, no. How are you getting 100 on this? I will say the one thing to kids that I try to, like, you know, if you're going to cheat, don't get 100. It's very easy for a professor to see that. What's up, Equity? Good to see you, dude. I'm not saying like you should intentionally get things wrong, but, you know, just a little bit of street smarts.
It's also very obvious to determine who will get 100 just by meeting them for 5 minutes.
Yeah. And this is the difference. Like, if I was like in person, this would be very easy for me to tell right away. But I'm having to play like this guessing game with online, and I don't know. It's just, I have to set up like little traps and things, because there's certain things that AI would get wrong, and then like sometimes it doesn't. It's annoying.
Like Sib, for example.
Yeah. Sib is very much not a cheater, because we know Sib. Sib talks all the time with us. Yeah.
98 or higher, I guarantee it.
98 Ohio? What's 98 Ohio?
98 or higher.
98 or higher.
I guarantee it.
Yeah. Sibley says, Sibley said, yeah, 98 or higher is what Sensation's saying for your grade. Oh, man.
Trust the years. Trust the years.
No, y'all did better on this exam, for sure. The grades are higher. They're definitely higher. Yeah. I think the median was like a 92. It's very high. So, congrats if you guys are learning more. I'm glad. Oh, it simply says thank you, Sensation. That's nice.
Yeah. You're welcome.
Yeah. Okay, but you did have a question, Sib. You said, for that rod inside the shell problem, the bounds were not supposed to be from 0, but for just the shell parts of B and C, and the rod wasn't in the middle. Let me go look at that, actually. Let me go look at that question real quick. Let's just do it. Unless other people have other questions. Probably good for me to like go over this stuff, because I might put it on the exam anyways. 1 second, let me go find it.
In relation to that question you were asking before, I already got about where I asked you the question anyway.
Yeah.
Is that a completely cyclical system? The battery charges the capacitor discharges into the motor does its thing, and then everything just runs out, and then it just cycles all over again every time wind wipers do that.
Yeah, it's completely just like it's closed.
Is that not horrifically inefficient though, from like
it
a
is.
mechanical
So
point?
I guarantee you that nowadays it's controlled by a microcontroller, but back in the day, they probably just had a fucking battery and a capacitor hooked up to it. Yeah. It's why, do you ever notice if, for instance, you know, like your blinkers, right? If one of your blinkers went out, that the other blinker would blink like really quickly. Oh, see, now the chat came up. Do you see that? Do you see that sensation above you? Now it showed up. Oh, weird. Okay, whatever. Some WebSocket thing. So yeah, in olden days of cars, right? Your blinkers were also controlled by like a relay capacitor system, and if one of your blinkers went out, like if it shorted, it would end up doubling the frequency of the other blinker, because now the circuit would only be charging one side, and so it would do it twice as quickly. I don't know. Did you ever notice that? Like, if you could always tell someone.
I've never seen him.
Oh, you never seen? Okay, in the U.S. for sure, you could always tell someone's car was fucked up because like their blinker would be like spazzing out, like going really quick. And the reason why that is because it wasn't charging the other blinker, and so the time to charge is then doubled, or cut in half. Sorry.
I was going to make some joke about we only buy German cars, so we don't have that problem. But I think I had Fords growing up, so.
Yeah, I think my British grandfather had a Ford Fiesta or something in the UK.
Good old 1.1.
Yeah, 1.1 liters. Dude, there are motorcycles that are bigger than that. Like what?
You must have come from quite a poor family then.
Oh yeah, my mother's side is like real poor, dude. My grandfather on my mom's side was like an olive farmer in like Sicily, and like came to the UK, and I think he washed dishes for like 20 years. Yeah. He like snuck on a boat. I think technically my grandfather doesn't even have like a UK passport. I think he's like technically an illegal immigrant, or like was, or something. Like my aunt doesn't have a British passport either, and I'm like, what? How are you living? You've been living in England for like 60 years. How do you not have a passport? But she has an Italian one. I don't know. I think they're a little bit more lax on the immigration laws over in the UK than they are over here, especially.
That's because of the distinct difference between the two fundamental immigration policies. So in America, or at least up until recently, it was just solely juice solely. So if you're becoming an automatic citizen if you're born on their soil. However, in Europe generally, it's just sanguine, birth by blood.
Birth by blood. Yeah. Blood by soil. Yeah, we call it birthright here. Which, like, I guess they're trying to get rid of or something. I don't know. Everything's changing. Got rid of. Nasser says, have I ever been to Italy? I have. I've been to Italy a couple times. I've only been to Sicily once. But I've been to Milan a couple times, Rome. All sorts of places. All right, Sib, let's see this question you had. This is question 9. Let's just do this one. So it says, consider an infinite length cylindrical shell that carries a non-uniform charge density. Wow, okay, yeah, so the shell, which here, let's use some colors and stuff. This is the shell, okay. That has a non-uniform charge density equal to alpha over r, and then Coulomb per meters cubed. In the center, there's an infinite line charge. And then we say you can assume that the infinite line charge has like some sort of radius, but really it's just like really tiny. We don't really care about it. Okay, cool. What is the total charge per unit length of the non-conducting shell? Oh, okay, cool. Well, if we want to get the total charge, right? So they're asking for like, what is q tot? Which is going to be the integral of dq, right? And in this case, that's equal to the integral of, we're going to say, rho dv. So it's charge density times volume. And then dv for a cylindrical shell is equal to 2 pi rl dr. Right? So 2 pi r gets you like the circumference. L gets you like the length of it. And so that's like the surface area of a shell, and then you do the dr, you just like keep stacking the shells out. Okay, so then this was equal to the integral, and then dr pointed from r1 to r2, right? That's the only radii that the thing's at. So r1 to r2, and then rho we said was alpha over r. So you got alpha over r, and then now you got the dv term. And so that's 2 pi r l dr. Oh, very cool. The r's cancel out. Love that. This cancels with this, right? So you're just left with integral from r1 to r2. And then everything else is actually a constant, right? Nothing else depends on r. So you have 2 pi alpha l, right? 2 pi alpha l, then just dr. Okay, cool. So then this is just 2 pi alpha L, and that's going to be R2 minus R1. And that's going to be equal to Q tot for the outside, which I think was the correct answer. Yeah, look. 2 pi alpha R2 minus R1. Nice. Okay, that one's kind of easy. Let's go get part 2. Yo, Unc, what's up? What's up, HHH? What's up, dude? What's up?
Stop. Twitch is broken.
Twitch is broken? No. What's wrong with Twitch?
Did you not notice?
No, I don't notice anything. Oh, Twitch chat's not coming up. Oh, let me fix that.
Twitch chat's not coming up.
Let me go fix it. Okay, now it should work. Harold says, I wish I was good at math.
Study.
Oh. There you go. Now say something here. Here, Twitch test. There you go. That should work. Yeah. There we go. Okay. Yeah. Harold, you can be good at math, dude. You just gotta try, dog. All right, let's try to do part B for this question, though.
Remember, if 1 + 1 = 46, you've taken it too far.
Put down the pen. What is this? Okay. Calculate the magnitude of the electric field when R is equal to 2.6. Yeah, I can definitely help you. Just submit a screenshot using the whatever. So R equals 2.6. Oh, that's outside, right? So that's way out here. Okay. And so if we want to figure out the electric field for that, right? We say E dot dA is equal to Q enclosed over epsilon naught, right? And for cylindrical geometries, we know electric field is going to go as a cylindrical shell. Like, so what you end up doing is you do E times 2 pi RL is equal to Q enclosed over epsilon naught. And the charge enclosed, okay, cool. So you're going to have positive charge from the non-conductor, from the shell, right? Which we already figured that out in part A, right? That was the total charge. So this was for the shell. What's the highest level of calc, Dr. Gold? Probably vector calc. That's probably the highest level of calculus you can do. So that's Q-tote shell.
Quantum calculus.
Quantum calculus. Oh, this one was total charge per unit length. Okay, so in our answer here, technically they wanted Q over L. Sorry, my bad. So that should have been Q divided by L, but whatever. So, yes. Okay. But then you want to multiply by L if you're trying to get the total charge, right? And then that was also plus the line charge. So line charge doesn't have a volume to it. It just has a length. So that's just lambda times L. So this right here, this is the shell. And this is like the line charge. Is that like Calc 3? Yes. That is pretty much Calc 3. Yeah. Vector calculus. It's like Green's theorem, Stokes' theorem, all the different ones. What's like, what is Pope saying in my chat here, dude? What? It makes no sense for the universe to split into two every time a wave function collapses, because you would have enough energy to create an entire universe. Like, I'm pretty sure the geometry of the entire universe copying itself is not realistic.
Finally understands. Well, no, that is exactly what's happening.
Yeah. Oh my God.
With every wave function collapse, a new universe is generated. That's literally the point. Yeah.
They're all parallel dimensions of things. Dude, anytime I watch Rick and Morty, I'm just like, wait, which version of this is, you know? There's like so many different Rick and Morty clones, I guess. They even had an episode about that. It's just like, yeah. Is vectors and parameters useful in calc? Yes. No, in BC Calc, somewhat. There's some parameterization stuff. But in terms, like, for life, yes. Very, very important to know, like, how to parameterize things. Okay. So. Yeah, I can try for you, H. Just let me get through this one first. Okay, so L's cancel. Right, we don't have any L's here anymore. So I'm gonna have the E.
Dr. G.
What's up, Sib?
Oh yeah, I was wondering for this one, the bounds, we wouldn't have to for this, like, one part that I think that I'm gonna, like, probably be asking for, like, partial credit is that for part B, what I did was that I recomputed part A, and then I put it from 0 to so the rod wasn't in the middle. It's just like peeking out or something. would be zero because it's hollow, right? There's no charge there. So putting zero to getting the balance wrong is
Oh, so you recalculated well, you already had this from part A, right? So you didn't need to recalculate this. This is Q of the outside shell. I agree that now you have another inside thing that's causing charge, but this is a line charge. So you don't need to integrate out with radius. It's just the line density, which is lambda times L. So for this one,
it would be
does that make sense? Or what were you gonna say, Sib? What's up?
Oh yeah, I mean, like you would consider it different. You would take them separately, pretty much, like the lambda L. I did put lambda L plus, but then I just recalculated Q enclosed for the shell. I thought the shell would be like merged together with that line charge.
Oh, I see. Yeah, no, the shell is still, nothing changes between part A and part B. The shell is still here. The shell is still just this, which means, and it only has. My mic disconnected real quick. You're good. Sorry. So the shell is still only has charge from R1 to R2. Like it hasn't like collapsed into this. It's this area here between the center and out to here. This is still vacuum. This is still like empty space.
That's what I did wrong. I put the balance from zero. Yeah, and I thought it was like if I put plus lambda L.
Well, interesting. How do you might have noticed that you would get an error if you tried to integrate that from but the charge distribution is 1 over R. Oh, I see. That's interesting. I see. Yeah. Usually, if you would try to integrate a cylindrical shell from 0 out to whatever the end radius is, you can't start at 0 because that would mean you get ln of 0, and that's like wrong. Because this row here, however, is alpha over R, it changes the electric field calculation such that technically you could go from 0 outwards. But although it's like discontinuous, because then that means the charge density is like infinite at the center. Yeah. I see. It's okay. That's a minor mistake, Sib. When you get your exam back, just tell me, and then I'll probably give you like more partial credit for it. But you were usually in questions we give you part A so that you use that number to then do part B. So just in the future, think that I don't need to redo part A because I don't think anything should have changed.
Thank you so much. I really appreciate it.
You're good, Sid. Equity says, Gold, for college graduation, is it similar to high school graduation where you have to get a certain amount of math, English, and other credits? Or do you only need to get credits for your certain pathway? No, you need credits. So you need what's called GE credits. So it's called general education. So, for instance, even though and that's dependent on your major. So as a physics major, I still had to take, I think it was like 2 English classes, like a history class, and some other like related science classes. So I had to take like 2 quarters of biology. I got out of 2 quarters of chemistry because I had AP credit. But that depends on the major. In high school, everyone has the same requirements, right? It's like take 4 years of math, take 4 years of English, whatever, take 4 years of history, you get to graduate. In college, it's different based on what college you go to, and then it's also different based on what program you're in within the college. This is also the difference between a BS and a BA. So when you go to get a bachelor's degree, you can get a Bachelor of Arts or you can get a Bachelor of Science. Bachelor of Science usually has more emphasis on the math and science requirements to get that degree, whereas a Bachelor of Arts, a BA, puts more requirement on what they call the not intramural, what do we call this, interdisciplinary, or like other fields. Like it's BAs are like more well-rounded degrees because you take more like language, history, whatever classes in addition to whatever your major is. But a BS is like almost strictly you're just doing science. There is still some, like, you still have to be able to speak English and stuff, and know some history. But yeah, it's dependent on a lot of different things. Which, I mean, hopefully you have a college counselor to explain that to you. Okay, so Qtote the shell, that was 2 pi a alpha, right? R2 minus R1. And then that was plus lambda. Okay, very cool. So I think we can kind of see where this comes from, right? So 1 over 2 pi, 1 over... Here, let's move this away. Yeah. This right here is equal to k times 2. So this is equal to the same thing as 18 times 10 to the 9th. So that's where that part comes from this. And then... Where do we get these other numbers? Oh, 3e to the minus 2. That's lambda. And then 2 pi alpha R2 minus R1. That's that part. And then divided by this. And then this is the 2.6. Yeah. Okay, cool. That's how you get the right answer. Okay. What's up? Yo, good to see you, Zach. So yeah, this one's correct as well. Cool. Shout out to Zach. Did you like all the calculus I was doing today, Zach? Well, it wasn't really calculus. It was like light differential equations. It was a first order separable Diffie-Q. Equity says, so if you do a lot of AP courses, can you graduate early in college? 100%. I don't recommend you do it though. I wouldn't, don't rush college. College is great. Unless like you're bleeding cash to pay for it, then yeah, maybe you can, get out of there as soon as you can, but don't rush the college experience. There's no other time in your life that'll be like that. So I came into undergrad with something like 60 credit hours from AP courses. And rather than, I could have graduated in like 2.5 years if I really wanted to. I dragged it out to 3. And then I took like 6 semesters of Italian. Like at that point, like you can just start taking other courses just to have fun with things. And so like I did like robotics courses. I did like an ethnomusicology course. It was just fun. And I also then took a year to
theory.
Lesbian dance theory. Yeah, sure. Yeah.
That's dope.
Do whatever you want. Like how college usually works is like once you pay for the semester, you can take as many courses as you want for that, like saying that single price. Like you're paying for like just the semester and then it's just like do whatever you want. So I had already like finished out a lot of my math and science, and especially a lot of my GE credits. I'd already finished out from AP stuff. So I just decided to fill it with things I wanted to look at, I wanted to study. And that's cool. It's a great part of things.
What I can suggest is avoid the course entitled How to Shout Meow at Chicken's Eggs.
Meow, 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 meow.
Meow.
Meow. Mistral says, can you do number 8 from the exam? Yes, sure. I'll do example 8. Do people need me to do part C for this question? And then H says, why'd you stretch it out? Because college is awesome. I don't know. Maybe it's different now, but when I was there, college was awesome. College was great. It's a very unique point of your life. You're around like everyone else who is your age. It's a great way to meet people. It's a great. There's so many like clubs and extracurricular things. It's like a playground, dude. It's awesome, and you can really learn whatever you want.
I got something on that. No, actually.
Yeah. Okay. What sensation have?
I've obviously legit, right? I've obviously never been to university as such, but I was quite close to a university.
Yes.
And they were just like, dude, just come down to our clubs. And so I went to Japanese language club like regularly, and they didn't give a shit that I was an outsider.
Yeah, no, that's great.
So I mean, if you're not even there yet, just do it.
Yeah, just go do the
join
clubs.
some random club at university.
Yeah.
Whilst you're waiting.
Zach says some people earn their associates in high school. Yeah, I forget what like an associate's degree is. I think it's like less than a bachelor's degree. I don't even know if that really does you much good in today's like workforce, but yeah, you can like earn degrees in high school. I
thought associate's degrees were our equivalent of A levels.
There you go. Yeah, A levels. That's what that is. Yeah, exactly. But yeah, and again, if you have a job opportunity already lined up, like I think H is talking about like a co-op. Yeah, if you already have an internship or something lined up and you're like, let me just go do it, sure. If you already know what you want to do and you're already passionate about it and like this is just the roadmap you're taking, you don't have to spend 4 years at college. But for a lot of other people, college is kind of a period of it's a very unique time in your life, right? 18 to 21, 18 to 22. A lot is changing. And you really get to like find yourself and like figure out like what you like to do and who you like to be around and what activities are important to you. And
who to go out on the piss with.
Yeah, exactly. Also, I don't know, it's a great experience for learning how to live on your own, which I know is a rare thing with these generations coming up where like kids aren't leaving their parents' houses, and I understand because
they can't afford it.
They can't afford it. I know. This is the hilarious thing. Like my generation got fucked out of the housing market, so all we do is rent, and like the next generation got fucked out of the rental market, so now they just stay at home. But you should get out of your parents' house. There's a lot of like vital, critical development as a human that happens when you don't have your mom like telling you to pick up your clothes, and like you have to go pick your clothes up yourself. Or like you have to go make yourself a sandwich.
See, I'm not the paranoid crank type, but I'm sure someone's pulling the strings because both of our countries have exactly the same problem.
I know.
Now, I don't know, we have similar kinds of systems, so you could sort of go with that. But then the same problem exists in every, I was going to say Western nation.
Western culture.
All of our former colonies as well.
Yeah.
So that includes New Zealand, Australia, and things like that are so far away from the rest of us that you would think it wouldn't affect them at all.
It's because the internet. The internet is the great unifying field theory of everything. Yeah, the internet enables everyone to have like the same experience, right? I feel like, well, not economic, but I would say socially. I would say because so many people don't go outside anymore or don't have human interaction. And like everything is online, social media and whatnot, you now have like a homogenous experience for a lot of people if they don't leave their house, right? Or the temptation is homogenous, right? There's, there's video games, there's all sorts of other entertainment things on phones, but things that like force people to not leave their house because they're like, I can just get my dopamine here in my living room. Yes, there we go. There's sensation. Yeah, it's like dopamine. Yeah.
Well, no, that was supposed to be. I'm so stupid I can't even use two thumbs.
BlackBerry or something. Man. All right, let me wrap this one.
Dr. G.
What's up?
Oh, for that part C, yeah, we had to go from R1 to 0.4 for the integral, right? Yeah, I went from 0 to 0.4. I did the same thing on part C.
See, I was going to come in from infinity, though. Let me see. So, here's what I would have... So, whenever I calculate electric field... So, I didn't ask for... I didn't ask for potential here? What? Oh, I did that in the other part. You know what's funny, Sib? When I first wrote this question, it was originally like a 5-parter. Like, there was also a part D and a part E. Because I wanted you to figure out the potential in here as well. And then I wanted you to figure out the capacitance. And I wanted so many things. And then I realized that this question was getting out of control, so I made it easier. Okay. So, yes.
It's on the other problem.
Oh, the other problem I had that? Okay. Because I wanted to do a potential and a capacitance, because I know we did that like during clicker stuff and office hours. Yeah, the electric field when it's equal to 0.4. So 0.4 is in between R1 and R2, right? So what happened was, so this equation is almost exactly the same, okay? Here, let me just copy it because it's pretty much almost exactly the same. No, that's not it. What? Come on. There we go. The only difference is you're not doing the whole shell. Okay. Now you have to do the integral of rho 2 pi r l, and then that's from r1 out to 0.4, I think. Yes. Yeah. So you're not doing the whole. This is only like part of the shell. Which, yeah, Sib, if you thought the shell went from 0 to 0.4, then that's totally going to change your answer, right?
No, I thought that, that rod in the middle, that's what tripped me out. I thought the rod in the middle means that, like, you had to include, like, that side view of the cylinder. I imagined enclosing that rod within the cylinder. So that's why I thought that, that's what it was.
Yeah, so you include it, you enclose it in the Gaussian surface. So if this is your Gaussian surface, right? You're enclosing like this amount of the shell, right? The green. And then none of the blue. And then you are still enclosing this. The difference is this Q enclosed just equals lambda L because it's a line charge. So you don't integrate out to here. Yeah. I can see why that's confusing though. I get it.
Okay, yeah, I did the same thing pretty much. Yeah, I went from 0 to 0.4.
Okay.
Yeah.
Instead of going from R1 to 0.4. Yeah, you're good, Sib. Yeah, we'll get you guys grades soon, and then you can submit things.
Okay, thank you so much.
You're welcome. Okay. Sorry, let me see through my chat. What's up, Nick? Yeah. My weekend was like, I honestly, like, I was really tired. I was pretty stressed because there was so much buildup last week with getting a midterm ready, and now I'm stressed again because I have to grade that midterm, and then I have to also get a final written, and then next weekend I gotta grade that final. So I don't know, there's a lot going on. I'll be happy once like the first week of August is done, and I'm just gonna like relax. Let me see.
Do me a favor, look at something for me.
What do you want to look up?
This isn't exactly on topic, but everyone's like, "Oh, that's fine," and I'm just like, "No, I need to do something different with that anyway." Right? Oh, this might take a minute.
Okay, go find it. I'm trying to
start talking.
You're good. You're good. I'm trying to find the question that question 8 that the other student wanted me to go through. Sibley says me too. Yeah. I'm like, wait, it's summer. I'm not supposed to be stressed. I'm supposed to be having like a fun time. Oh, someone's asking like, where's the? I posted it so many times. Okay.
Okay, there we go.
What'd you send me here? Oh god. Oh, is this like throwing axes and stuff? Oh,
it's a thing for the festival.
Oh, let's see. Okay. That looks like Sensation. Some of this kind of looks like you. These people look like you a little bit. Are these Northern England people?
Not some of them, yeah.
Thirsk Youth Club. Where's Thirsk?
Where I am.
Oh, okay. Oh, nice. You got a little bar. Oh, you got cute little badges and stuff. You got slushy machines. Refills for only £2. Yeah, this is called like a farmer's market in the U.S. That's what we call this. What do you guys call it? Like a fair?
This is the festival. Yeah.
Oh, it's called a festival. Yeah, this is not really a festival for us. This is, I guess there's some festival type things. Where's the DJ? I said they got the bouncy house. Where's the DJ? Where's main stage? What was I pulling up? Pull up this question. Okay.
But anyway, apparently that's perfect, but I don't think so.
You think that's a perfect festival?
No, I was just given a load of photographs and I was told to do. I wasn't given any direction. I was just told to do something with it, so I did.
Oh,
that.
you created that video.
Yeah, I was just given a load of still images.
Oh.
And there was
No, that's
and they were
pretty
like,
good.
just do something. Do something.
Oh, I
with
like that. Oh, I like that sensation. I felt like that was professional, dude. What? That was really cool. I didn't realize you did that. Yeah. I thought you wanted me to like rate that festival, and I was like, it's kind of like it's an okay festival, I guess. No, the video's great though. Oh man.
I don't know. Maybe I'm just never happy with my work.
No, I mean there is a common thing in life that with perfectionism, and we're never happy, with our end result. We should be. Okay. Sorry. Yeah. And then I'll do something like this. This one, yes, I understand this one like confused a lot of students. But again, I did this one on 2 different occasions in 2 different office hours. So, I don't know. I know it looks ugly, but if you had seen the trick at least one of the 2 times I did it, probably 3 times, because it was also on your homework, then you would have been fine. Okay, so point B is here. And that comes up to like a C4 and a C4. So this is going to come up. Then we got C4 here. And then we got C4 here. Okay. And then I'm going to deal with this part later. I'm just going to use this connection first. So there, I have connecting to a C2. Slackers? All right, here. Well, anyways, there's a C1 over here, right? Let's just, well, here, let me use different, I want to use consistent colors here. I'm running out of colors. Okay, this is purple. Okay. And then let me move this down. Okay, so you have A here. And then you have this, which is C1. Slackers is, yes, that's the correct way to spell slackers, Nick. Anyways, okay. Oh, no, I need a different color. Ooh. Okay. So this came here to like one of the C2s. And then it went to another C2. Okay. And then we had this, which like connects the 2 C2s. Right? You see how like from here, from C4 all the way to C2. And then it also connects to here, which is C3. And then blame the autocorrect. I don't think autocorrect would have done it that way, dude. Sorry. I don't take that. That's not a valid excuse. Okay, there we go. I tried to draw this as best I could. So, this is kind of the equivalent circuit of this, which actually doesn't look too bad, because, right, this is C1. The key thing here is you say that there is no, like, capacitance effect from C3. Because these lines are in parallel, so they're going to be at the same voltage, and if they're at the same voltage, there's no voltage difference across the capacitor. So there's no capacitance. So really what you just have is this. This is C2, this is C4. And then you have this. And this is point B. And this is point A. Okay. So the first thing is to put these are series capacitors. So they do that weird addy thing where it's like the inverse add. So I say C24. So let's like group these together, right? That's going to be equal to 1 over C2 plus 1 over C4, all to the negative 1. Okay. But then those two things are in parallel with each other, so they're going to add in series. So sorry. I need just to freehand it, sorry. C1. What's up, Ethan? I had C1 and C2 and C4 in series on top, and C2 and C4 in bottom on series. Oh. Yeah, well, okay. C1 is kind of like in series with C2, but it's also in series with this C2 as well. So in reality, it's in parallel. Like these two things are in parallel with each other. And then in series with C1. You're coming back from work? Circuits. We love circuits. Yeah, circuits are great. I think circuits are dope.
That's dope.
I think they're really cool. I don't know. Ethan, why'd you have to work today if you weren't supposed to work? Didn't you just get back into like Belize? It's kind of rude. Okay, so this is B. This is C24. This is C24. So if you want to combine these now, right? These two are in parallel. And so parallel things just add up. So that's equal to 2 C24. Okay. And now your final thing. C1. A. You have this. You have 2 C24s here. And now you just have these in series. They gave me my day off now. Okay, cool. Going home. What are you going to do when you get home? And so then this is, so C124, or like, we'll just say C total at this point, is going to be equal to 1 over C1 plus 1 over 2 C24, all to the minus 1. Do I get some partial credit for working? I guess I placed a C1 wrong in my drawing. Yeah, probably. Yeah, I'll probably give you some. I mean, yeah, you'll definitely get some partial credit. I'm not going to give you 0 points. Anyways, that's how you do that one. A little tricky. Dr. G, I thought you could always use a different color for every wire and it would tell you whether something's in series or parallel.
Nice.
You could. On the current homework, it didn't work. Uh-oh. Go find me what question it doesn't work on. I'll take a look at it. Tell me which one doesn't work. Thanks for the follow, Pilardo. Dun 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 dun.
That's dope.
What's up, Mondo? Mondo Thighs is here, dude.
That is also sus, but for a different reason.
Mondo Thighs, World Thighs. It's because he claps cheeks on the finals, dude. Mondo Thighs is like the master finals player at this point. He's played so much finals.
Of course. What? I'm an idiot. Why did I not make that connection?
Yeah, Mondo Thighs, World Thighs, clapping cheeks. Yeah.
No, Mondo. It means the world, but it was slang in the 80s. Mondo.
Oh, was it? What was it slang in the 80s for?
Rad, tubular, gnarly.
Oh, Mondo. You say Mondo, be like Mondo. Oh, that's cool.
I bit before my time, to be honest, but yeah.
Mondo.
That sort of that surfer slang that somehow made it across over here in the 80s.
Oh, that's cool. What program do you use for the infinite canvas? Are you talking about this, like the infinite canvas? I use Group World. It's a company. They're kind of old school, and I'm sure there are like better options out there. But I've used this for like the last like 10 years, so it just works.
Illustrator.
Yeah, I mean, there's like Microsoft whatever that's even better now. Mondo says, I first heard Mondo with Mondo Burger in the movie Good Burger. Oh, okay. Welcome to Good Burger. Can I take your order? Home of the Good Burger. But then came with Mondo pies. Brondo. Yeah, that's from dude, we need to all rewatch that film, dude. Idiocracy. We're living in it.
Electrolytes.
Plants crave, dude.
That's what plants crave.
That's what plants crave. Okay, nice sib. I see that. Cool. Like that. HHH, bro, are you still here? You want me to go over this one for you? The very long metal rod. Oh, this is actually kind of cool. Just the right magnitude to make the whole construct electrically neutral. Calculate E for R is less than A. R is between A and B, and R is greater than B. Yeah, okay, cool, dude. Yeah, this is a very similar question, actually, to the exam question that we had. This one. It's very, very similar. The only difference is this was a non-conducting sheath. Yours is a conducting sheath. But they also say it's very thin. But where is B? Okay, well, whatever. but who was phone? Okay, we're gonna say that this length is A. You were lurking at the stream. Nice, Ethan. Well, tell us when you get home. You can do stuff. And this has like positive lambda on it. A very, very thin conducting sheath. I'm gonna assume that the conducting sheath is located at B. I assume that's just like missing information, right? Yeah. Okay. And then this here is B. Okay. I keep hearing like chat noises. Where are my chat noises coming from? What? Fuck. Oh, it's because of campus wire. Okay. Okay, cool. So this must have a charge of negative lambda, right, man? In order for the whole thing to be neutral. So then this is very easy. I'm going to go in like reverse order here. Well, actually, no, I don't even need to. Okay. So for R is less than A, because this is a conductor, that means that all the charge is only on the outside. So for R is less than A, Q enclosed is equal to 0. So E is also equal to 0. For between A and B, okay. Well, now you just have like E times 2 pi R. Did they give you the length? No. Well, whatever. 2 pi RL is equal to lambda plus lambda L over epsilon naught. L's are going to cancel. And so you get E is equal to 1 over 2 pi epsilon naught. And then that's going to be lambda over R. And then for R is greater than B, again, Q enclosed is 0. Because now you're enclosing minus and positive charge, which is neutral. And so E is equal to 0. Dude, what's with all this caps, bro? This dude, like, chill out, dude. Be explicit and explain the surface integrations. Okay. Hey, here, if you want to explain why many go to 0, it's because the enclosed charge is 0 for A and C. So then if you want to calculate, if you want to, like, draw a graph of, like, E versus R, you have like 0 up to A. And then you have a sudden spike, and then it goes down as 1 over R. So that's going to look like this. And then At B, it again just like goes to 0, and that's out to infinity. Yeah. Does that make sense? H. 6 H's. Yes, cool. Nice, good job. You're welcome.
Well done! Well done!
And then
Wait, I'm just some of the students don't know like where the survey is or where the link is. Sorry. Didn't someone post the link somewhere? I think it was post 174. Oh yeah, here's the link.
oh yeah, here's something that somebody pointed out to me the other day. Have you ever seen the RoboCop movies?
I haven't actually seen any RoboCop. No, isn't there a new one?
Not for a while.
Okay.
Have you ever seen the Terminator movies?
Yes, I have seen the Terminator movies.
Okay, so the weird thing about both of those series of films is the first one starts out really R-rated, very violent, full of blood and guts and gore and horror kind of aspect through it all. And the longer that the series went on for, the more PG it became.
Oh wow, they just started realizing their market, dude. They're like, we can sell more action figures if it's actually chill, right?
It's just very, very strange how both of these series of films started off as, adult movies.
And then they eventually had like a kid base to it, yeah.
Because they both made it to TV and then had TV series. And yeah, it was very
TV.
Very
You definitely can't. You can't have.
point.
Yeah, you definitely you can't have rated R stuff on TV. Like that's just unless you're going straight to HBO, I guess. You know, what I always want to watch was Judge Dredd. I never watched Judge Dredd. That was like kind of another like RoboCop type film, right?
Yeah.
Ish. You know, kind of like
more fun. Jesus.
Oh Jesus, Ethan, your mic, dude. What's
Hello,
up?
something up?
You're okay. What's up?
Sorry about that. My mic was just on the bed.
Yeah, you're okay, dude.
But yeah, like I was saying, I was going into work and then 37 minutes later, I thought, but they realized I was not supposed to work today, even though I asked them and they told me to work today.
So they sent you back, or like you just stayed there?
They said if I didn't take this day off, I would not have another day off until next week. So.
Oh, but you already got there, dude. I would have been like, yo, I'm working, dude. Like I'm already here. Right?
Yeah, swap me out with someone else.
Yeah, tell someone else fucked
Mondays
up.
are slow.
Oh, Mondays are slow.
Not for real. Mondays are slow for me when I work there, so I don't think I messed up.
Okay, that's okay then.
But yeah, I mean, now that I'm here, I could at least ask my question and get.
You can ask your
first.
question, yeah, and you can get your points, yeah. Submit a screenshot. I'll go do
It's
it.
not here. I'm not here just for points. I'm also here to learn. Remember, that's the entire purpose of this channel.
I'm glad you're here to learn. Ethan is on the right path, dude. Ethan knows what's up.
Just give me some time.
All right, I'll give you some time. Okay, yeah, Sib, this one's kind of a pain. Because, yeah, I got to, like, the positive end here, and I got to the negative end here, and then, like, there's, like, what's all this garbage in between? Like, what's happening over here? Okay, the first thing I'm going to recognize, right, is that these things are connected in series, okay? So, I'm going to say that RDE is just equal to RD plus RE. Okay, agree with that, cool. Uh-huh. Okay, so let's try to like redraw some stuff real quick. Let's say this is the positive, okay? RA. And then from the bottom, we know we eventually have to get RF and RG, right? So RF and RG have to both feed into the bottom here. We might have to use like a loop law. I really don't want to. but we might need to. And RF and RG are parallel to each other, right? So we got like, this is RF. This is RG. Okay, and then let's think about like what happens with these connections. So RG connects straight to RA. It really does, right? So let's just try to like draw some connections here. Oh, this might be a Wheatstone, honestly. So RG goes to RA. And then watch this. RF. RF goes... Oh, yeah, Sib, you can come speak. Hello, my electrical... Yeah, dude, my electrical engineers, dude, this is kind of a mess. Who wants to do mesh analysis for me, dude? That's the other way to do this. Okay, so RF... Man...
You know what happened to me on this one is like I always draw the colors like that color method, putting colors between every wire, and so I combined that RE and RD together.
I agree with that.
And then I combined that with RC because when I redrew it, like where RD is, then it seemed like that would be in parallel because that color method.
I agree. And then that should also be in parallel with RB, right?
Then it didn't work, and I'm on attempt 4 out of 5 on the homework, and that hasn't worked.
Wait, I allowed 5 attempts on this homework? Did I allow 5 attempts on this homework?
Only on certain questions. Only on certain questions.
Okay. All right, well, here, let me see. I mean, the thing could be wrong, honestly. So let's assume this and this, right? Do you see how, like, all of these connect to the same endpoint? So... Let's just try to consider what the hell this thing is. Okay. So that component is going to be RD with RE, right? And then you also have in the middle, you have RC. And then down here, you have RB. Okay. And yeah, notice how the ends of all these all eventually... I could always move these to like the same spot. That always connects to like an orange part. So this has one terminal up here, right? That's what this corresponds to. And then it has... this terminal down here, which is where like all these connect to. Okay. So, ooh, I kind of like this. So, okay. RF comes up this way. It connects in between. I think I see it. Let me call this something special, Sib. Let me call this like RBCDE. Okay? Because the way I see it, RBCDE lies like in between these two. Exactly. Right? Which means it lies on the orange end of RF. So one end is going to be here. And then the other end needs to connect to the purple that joins RA and RG. Or the two ends of those. Oh. So this like goes into here. Oh, fascinating.
Dr. G, so some of them can be like not in series or not in parallel, because Albert was telling me that, but it confused me about some of them are not in series or parallel, and it didn't go with my colored method.
Yeah. So this one, I think the question is like, is this in series with this? Man, what a strange. Oh. I think I see it. This one, this blue one is in series with RF. So this is R, B, C, D, E. Let's instead, right? Again, you can always move wires. You just I'm gonna move this like up, like this way. So that you have like this. Yeah. Okay. This is it. I'm pretty sure this is it. Which, wow, that's a pain. What are all these numbers? What? Why they put R8? Why are there all these different numbers? Also, why did they give voltages? We don't need voltages. I wonder if there is a easy way to do that. Okay, do you get to here, Sib, at least? Does this make sense? Because now this is in series with this. These two are in parallel with each other, and then they're in series with RA.
I guess, yeah, I guess I was just confused because I thought that some of them weren't in series or parallel. Yes, now I'm having trouble like keeping track of even what I did, but
I know. Well, I mean, no, it has to be in series or parallel at some point, right? Things have to connect somehow.
They have to be, right? It can't be stuck.
Can't be stuck. I mean, the only way you can have things like kind of stuck is if you have like this, like this situation. This is like kind of weird, and that's like what's called like a wheat stone. And I forget the ways to do this, but you have to do like some loops or something. But in this case, right, this is like, I think what Albert's trying to say is that, for instance, this is not, this one is strictly not in series with this because there's also something like kind of in between it. But then also, this is not in parallel with this because this is also in between it. So you can't just say that these two are in series, these two are in series, and then this is in parallel with this, because you have something in between that's screwing it up. But I don't think you have anything here that screws things up.
Like, for example, if I combine RD and RE, and then I combine that with A, wouldn't A be...
No. Yeah, that you can't do. Yeah, no. So you're saying if I...
Yeah, why is that?
Okay, so you're saying I want to turn this into a resistor, right? And then I want to combine it with RA?
Yeah.
The issue why you can't do that is because there's all this other shit trying to like get in between it. You need a straight connection just from RD to RA with no interruptions.
Oh, so in this case, like putting a different, like if I put a color there, it just say, like thinking that one color meaning like at least one shared wire, that method wouldn't work in that scenario.
Yeah, correct. I mean, it's because it's a junction, Sib. So like, you're only allowed to connect things that, you know, go to like the same junction. This can't cross over to here because now you have this stuff happening as well. If all of these were gone, so if you didn't have this, okay, let's say these things were not there, then you could connect the RDE with RA in series. But because you have other things like trying to come in on it, you can't just say that these two things are in series with each other.
Oh, those would be two different colors.
Yes, exactly.
Oh, okay.
But for instance, these are all kind of the same color. Like, again, the visualization is kind of tricky, right? This is all the same color. Yeah.
As long as anytime there's that junk that like branching off, you can never go past that, like make that the same color. But as long as I watch out for that, there's no other scenario
like you can't do this, for example, right? Yeah, this can't just go straight over to here because it also has this stuff happening. So in reality, here I'm going to show you what actually happens. Okay, is that all of this is actually connected to the same thing. This is all like this, okay? And that's what makes, for instance, RBCDE, which is all this stuff, is technically in parallel with RG as well. What's the sign of the current? Yeah.
So you can't combine them?
Yeah, you can combine these. Yeah. But watch what happens. So sorry. Let me. And then here, we'll just say like this. So, but here's the issue, Sib. If you turn this into a single thing, like let's say this is all just like one green thing, you can't have this just connect in series with A, because you have to also consider all of the things happening here as well.
If I don't combine it, then I can?
Yes. So watch what's happening here. So this, right, which is RDRE, that's in parallel with RC, which is in parallel with RB. Okay? And so that whole thing is also in parallel with... Well, no. It has to be in series first with RF, and then you're allowed to say that it's in parallel with RG. And that is then in series with RA. Oh, I see. Oh, man, this is such a mindfuck. You know what it comes down to? It comes down to you have to look at like what the signs of things are. Okay, so wait. This is positive, right? This is negative. This is negative. Okay. So then this would be negative, this would be positive. This is positive, 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 negative, 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 positive, negative. Okay. Yeah. That's why these two can't just, actually, you can't really connect RG and RA directly to each other because they have two different charges. Bro, this is so easy. We're taught this in high school. I'm glad you're taught it in high school. Congrats. Because watch here, Sid. This right here is positive, yeah, from RA. And then we have a minus sign here. But the minus sign then connects to the positive from RG here. Yeah, okay, that makes sense. Wow, what's up? What's up, Cuber? I might be confusing myself more. God damn it. Wait, no. Negative, positive, negative, positive. Yes. You played for 7 hours? Wow. Wow, Cubes. That's crazy, dude. This is Los Angeles, dude. Yeah. Let me see. RBCDE is then in series with RF, and all of that is in parallel with RG, which is then in series with RA. Yes. Oh, man. Yes, I see it now. It's hard to see with all the pluses and minuses, though. But that is the reason you can't just, like, group all these together. It's because, let me do another example here. Let's say this is positive, right? And you come into a resistor, right? So this is positive, this is negative, right? And then you have positive, and you have negative, and then this comes back. Okay, cool, great. That's two things in series, right? Series is when you have the positive end of, like, one thing, like the opposites. I'd say it's like head to tail. Whereas when you have things in parallel, again, this is positive, this is negative. Let's say you have this, right? This is positive, positive. And these are both negative. So here the negative ends connect together. The positive ends connect together. And this is being in parallel. In this case, you have the positive end from something connecting to the negative end of the other. That's called series. Sensation, be nice to him. This is series.
Mother chod.
Mother chod. Okay, so in this case, since all of these things are minus signs, that means that this thing is in parallel with this thing, which is in parallel with this thing. Because they all have minus signs, and they're all connected to the same, like, point. These two are in...
Sorry.
Yeah.
Oh, sorry. How did you know how to distribute those, or how do you distribute those signs? Like the positive or negative?
Good question. One sec. Positive, negative. Wait, and that's in... never mind. I had this wrong. Sorry. One sec. I'm gonna get this right. Had this flipped. Think about, like, from the battery, Sib. Okay? So if we're coming straight from the battery, this is positive. So anything connected straight to the battery is going to be positive. And then after you cross the resistor, you're going to be at a lower potential because you lost potential going across the... Yes, thank you. Pilardo has it right here. You reverse signs when passing through resistors. So this reverses to negative. This was a negative, which is going to reverse sign to positive. This is a negative, which is going to reverse sign to positive. So then when we come over here, this is still positive. This is still positive. This is still positive, right? Positive, positive, positive. Notice how we haven't gone through any more resistors as we do this, right? We're still just a wire.
Oh, that's why that's positive.
Mm-hmm. But then when I go across this, now I reverse signs again. So this is minus. This is minus. Going across, this is minus. Oh, so is this minus and this is positive? Wait, one sec. Fuck.
I thought that was a thing where they're in parallel. You can just contract them back to being in series.
You can't. Yeah. I'm pretty sure this is positive. This is negative, though. Wait, one sec. No, it should be minus positive then. That's whack. Wait, really? But wait, when we do this, guys, right? When I go across a resistor, right? Positive to negative. I don't think I go negative to positive. That doesn't make any sense. Right, Pilardo? Why is there a negative to the right of RA? Shouldn't it be positive because there's no resistor in between them? No. So, if you're coming from a positive potential and you go across the resistor, then you're negative. Well, the whole network is not in series. This is what we determine to eventually be the network. You have RA, which is in series with this network, but here RBCDE is in series with RF, and then this thing is in parallel with RG. And then that whole thing is in series with RA. One sec. I think this is still minus, guys. I think it is. One sec. I'm gonna fix this. How the circuit's going? Dude, they're hurting me so much, dude. I'm in so much pain.
Oh, no.
I did find out eventually what this is, but I'm trying to come up with a systematic way to do it. Oh, you're okay, Pilardo. I thought you knew more than me. It's okay. It's okay, dude. Because it kind of does make sense. You do change polarity. Yes. Yeah, you could. Anyways, okay. I think this is minus. And then this is plus. I think this is minus. This is minus. This is plus. This is minus. This is plus. This is plus. RBCDE is then in parallel with RG. And it is. Cool. This is in parallel with RG. And then RBCDE is also in series with RF. Oh,
yeah,
man.
dude, get one of those simulators.
You want me to do a simulator? I can do a simulator with it, yeah. Okay.
Because there was that one I used to play with. I forgot what it was called. I'll have to find out later. But basically, it had animations and everything. So if you did it wrong, it would like tell you.
Yeah.
So basically, if you attached an LED straight to a battery, it would just blow up and it would go boom.
Let me see how I can do this. It's there are like cool little simulators on this. What am I thinking about? Circuit simulator.
I was so young and so stupid, I didn't understand why.
I think it's called
Just
PHET.
an LED straight to a battery would just make it blow up like that.
Yeah, I think this is it. This is what I want.
Well done, you scattered the room in shrapnel.
One sec. I need my Kudu to turn off. There we go. Circuit Virtual Lab. Here we go. If you really want to do it, right? Okay, so we have battery, right? And then we had. It was like wire. Wait 1 sec.
LED.
Here, let's put resistor. And then there's another wire coming down here. But then there's a resistor here. And there's a resistor here. Oh. Oh, here. Well, let's try to like get things a little bit nicer. We use this in your class? That's cool. I wonder if it'll get it right. We'll see.
Can you change that, or does it have to be the weird things?
What do you
Can it
mean
not
weird
be like
things?
actual? Can it not actually be like circuit diagram stuff?
No, well, maybe. This is just like some basic baby thing. Let me see. Well, I should get rid of this one so I can like show the wire.
Show all
Okay,
them
cool.
wires.
And then all these things meet. They all meet. They all meet right here. Okay. Okay, very cool. Oh, let's see it. Okay, there we go. Fascinating.
Now put a voltmeter somewhere.
I want to show conventional current though. Okay, there we go. Yes, I agree. I agree, Femvox. I agree. But let's look at like the direction of the current, okay? So this is let me screenshot this. Okay. Let's see like how correct I was with things. Okay, yeah. So current always flows from positive to minus is the key thing here. So current is flowing this way. And then it is flowing this way. That's positive minus. And then it is flowing this way. Okay, cool. So we are consistent with that. And then I'm consistent here as well. Positive to minus flowing that way. Positive minus flowing that way. Positive to minus. Positive to minus. Okay. All right, so all my things are all my pluses and minuses are the same, which is great. Okay, cool. I think it's pretty safe to see that like this whole thing must be some new device. Here, let me can I copy this maybe? Oh no. Right, so this whole thing right here. No, come on. There's going to be some new resistor, which we're going to call RBCDE. And then this comes into here. Okay. Ah, okay. So, I see that RBCDE is now in series with RF, right? And then those things are in parallel with RG, and then that whole thing is in series with RA. And is that what we said earlier? Yes. RBCDE is in series with RF, all of that's in parallel with RG, and then all of that is in series with RA. Does this look a little easier, Sib?
Yes. So you for R, B, C, D, and E, you combine those all in parallel, or you first combine the D and E in series?
You first D and E combine in series, and then all of that's in parallel with B and C. Okay.
Okay.
And then,
that's parallel.
Yeah. So D and E are in series, right? These are in series. And then you have parallel. Okay. So the three of those are then parallel. And then once you have that, that thing is in series with RF. Here, let me just like get rid of this. Okay, so now you have like trying to like draw these together. This is like RBCDE in series. Series I usually write as a plus with RF. Okay. which if you're looking at, is now, this is RA. And the end of that has these two ends both connecting to each other. So now you have RG here, and then also RBCDEF, and then those connect to eventually to the voltage here. So then these are in parallel. This and this. Sorry, this one and this. Can't use the same colors. This one and this one are in parallel with each other, which is this, and then that is in series with RA. And then you're done. No, we like the fugly Jackson Pollock. Okay, yeah. Oh my god. Here, so I'm just gonna give you the answer to this one because this one sucks, dude. What was it?
Hey,
It was either
thank you so
that. It was
much.
either that.
What were you saying, Sensation?
It was either that or Edvard Munch.
Munch.
The screen.
Oh, Munch. Yes. Wow. Oh, there's another mode of it. Oh, I love that. Oh, that looks beautiful, Shantrix. Very nice, dude. We got prettiness Shantrix has. Question 11. Here, Sib, I'm gonna DM it to you here or whatever. But it's, was this question 11? Oh, and then they're gonna make you do the current? Oh no. It's gonna get so bad. Okay. No, Min says go to question 11. Pilardo, yeah, nice, good. Thanks for seeing us. Where are you from, Pilardo? Before you leave, just to tell us. It's always kind of fun to see where everyone's from.
Well, somewhere around here, I would imagine. If he's going to sleep.
Yeah.
He's German. Spain.
German. Spain, Sevilla. Nice. That's cool. Well,
I
yeah.
still can't
Buenas
get
noches.
Spanish down.
You can't count in Spanish? What?
No, I still can't get Catalonian Spanish down.
Oh, Catalan. Yeah, Catalan is different. Yeah, for sure.
Thank you so much. I really appreciate it.
You're welcome, Sibley.
Thank you.
Mm-hmm. Buenas noches.
Buenas noches.
Buenas noches. Buenas noches. Noches.
See, I don't even know where you actually make the lisp sound.
Yeah, I don't either. Yeah, the Spanish lisp is getting interesting. So, buenas noches. Capital of Andalusia. Well, because like it's in Ibiza, right? Ibiza. Instead of Ibiza.
See, that's interesting because Ibiza is spelled with a Z.
Right. Yeah, but they put the th.
Yeah, because we always grew up calling it Ibiza, but I imagine it's not Ibiza. I imagine it's Ibiza.
Ibiza, yeah. Okay.
But then that's the fault of the Venga Boys, if you remember them.
The who boys?
The Venga Boys. Very popular sort of late 90s, early 2000s.
I don't remember them, no.
We like to party. We like
to party. Okay, I know that one, yeah.
So Venga Boys. So they did a song called We're Going to Ibiza. Oh, but they said Ibiza, and everyone went fucking sick and went, no, it's called Ibiza, sort your head out.
Oh, wait, Sib. Oh, no. Oh, wait. Sib, question 11. Question 11 has a random part. It's RA plus 8. I don't know why the answer is just RA plus 8. Oh, you know what it is? Oh, that's cool. It's because the equivalent resistance of that whole clusterfuck network before RA is 8 ohms. Yeah, that's what they say. Sorry.
Here's a question for you. What can it be used for?
Yeah. Why do people say Z instead of saying Z? I don't know.
And people don't. Only the Americans say Z. Even the Canadians say Z. Everyone else that speaks English also says Z. So it's the American Z is the exception, not the rule. Even the Japanese say Z.
Wait, Sib's type.
No, it's not British English that says Z. It's all the other 52 countries that say Z. And they're not all former British colonies. Some of them are German colonies. The Germans say Z. The French say "fuck off, English twats."
Oh man.
It's kind of funny though, because they swear I'm English, and then when I say actually I was born in Scotland to a Scottish family, and their demeanour instantly changes.
Why does it instantly change?
We haven't, because we were allies during the English occupation, the English aggression.
The occupation, the English aggression. Yeah.
So yes, even to this day, if you tell them you're Scottish, their demeanour instantly changes. It's really quite fascinating to watch.
Dun, 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 dun. Okay, sorry. Min, what you need help? Question 6. Okay, let me look up question 6 real quick for him. Oh. I think we did this one. Did we do this one in class? I feel like we did this one in class.
Je suis un mage.
Oh yeah, the value. Yeah. Sib, you gotta take the value and add 8 to it, whatever it is. So whatever you see your resistance for resistor A, just add 8 to it. Okay. Min was saying, yeah, how to set up the loops for this one. Okay. Wait, did we not do this one during class? I feel like we did. I feel like we did do this during class. Let me go find it real quick. Oh, it's question 5. Okay, that's different. I was like, I'm pretty sure I did the loops for 6. Yes. Okay, the loops for 5. Yes, we did 6 in class. Okay, that's fine. All right, but yeah, 5 looks like a mess.
You have to tell me some kind of practical application for this.
I don't know, this is just like circuits. It's like really confusing shit sometimes. Okay. Practical application. Sometimes you do have like really complicated circuits with a lot of components, and you're trying to like figure out what the equivalent like resistance and current is. Just the circulation is fine. Okay. So, no, we're not time limited. Well, yeah, I'm probably not going to solve the whole thing for you, but yeah, wait, shit. I do have to do something. 1 second. Let me check my calendar. Okay. Yeah, I still have like 23 minutes. But I also have some other students that are waiting, so let me do the circulations for you. Let me do this one first. Okay, doing this one, we're going to call this like loop A. Okay. So for A, that would be, so V1 is the first thing you have, and then you have minus I1 R1 minus I3 R3 minus I2 R2 is equal to 0. The bottom right loop is a confusing one. That's fine. Okay. Again, just whatever direction the currents are, that's what you have to obey that rule. So here, if we're going this way, so we're going across a battery positive in the same direction, so that's going to be V2. Okay, but then as I come this way, watch what happens here, Min. Do you see how I'm going against what I said the current was? You see how as I cross R3, I'm going opposite to the direction of the current. So instead of dropping voltage across that resistor, I'm going to add. So that's going to be plus I3 R3. But then this is in the same direction, so this is minus I5 R5. And then that's equal to 0. And then here, I'll do this loop as well for you. Let's say we're doing this way. So V2 across. Then we're going in the same direction as the current, so that's going to be minus I2R2. But then coming here, this direction is opposite to I4. So that's going to be plus I4R4. And then that's equal to 0. I don't know why they tell you I don't really care about IB. I don't think I care about the current in IB. Yes. Okay. Got it, make sense, yeah? You're welcome, dude. Okay. Let me do some of the other students' questions that have been waiting. Let me see if I can do Chantrix's real quick, and then Ethan, you're next. Suppose that A and R are real numbers. A geometric sequence with the first term A has a common ratio R has 4 terms. The sum of this geometric sequence is 6 plus 6 root 2. A second sequence has the same first term A, but a different common ratio, but has 8 terms. The sum of this second is this. Determine all the values for A. Okay. So I just need the sum of a geometric series equation. Okay. So the first one is how many terms? 4. So S4 is equal to A. And then it's some common ratio. So then R to the 4 minus 1 over R minus 1. And this is equal to 6 plus 6 root 2. Fascinating. And then a second sequence has the same A and the same R, but has 8 terms. So then we say S8 is equal to 8 R to the 8th minus 1 over R minus 1. And that's equal to 30 plus 3 root 2. Oh, okay, cool. Determine all the possible values of A. Well, I see this is like, I see that like S8 is equal to 30 root 2. It's equal to, yeah, sorry, there's a 30 here, not a 3. Yeah, so what I notice here is that like S8 is equal to 5 times S4, right? You see how this is a multiple of 5? So if we do S8 over S4, we should get 5. And that's equal to A, R to the 8th minus 1 over 1, R minus 1, divided by A, R to the 4th minus 1 over R minus 1. Cool. A's cancel. R's cancel. Assuming that R is not equal to 1. And so I get 5 is equal to R to the 8th minus 1 over R to the 4th minus 1. It's like a difference of cubes. Difference of squares, maybe, right? It's the same thing as R to the 4th squared minus 1 squared over R to the 4th minus 1. So this is the same thing as R to the 4th minus 1, R to the 4th plus 1, all over R to the 4th minus 1. Ooh, these cancel. So 5 equals r to the 4th plus 1. R to the 4th equals 4. R equals the 4th root of 4. Which is, yeah, plus or minus square root of 2. Is that right? Yeah, 4 to the 1/4. It's the same thing as 2 squared to the 1/4. So it's 2 to the 1/2. Yeah, cool, fine. Square root of 2. What's up, Mr. King Awesome? Cool, man. I think I see your question. Yes, it's a circuit question. Wow. Okay. I'll try to do that soon. Okay. R is plus or minus the square root of 2. All possible values of A. Interesting. I think when I sub that in here, right? I should only get like one solution for A, no? Right? So, square root of 2 to the 4th is just 4. So 4 minus 1 all over r minus 1 has to equal 6 plus 6 root 2. Wait, but this is square root of 2. A equals 2 is one solution. He says it's an easy one. So I think there's two solutions for A, right? Because you can have one where it's square root of 2, and then you have one when it's not, right? When it's negative. 3A over plus or minus square root of 2 minus 1 is equal to 6 plus 6 root 2. Divide by 3. A over plus or minus square root of 2 minus 1 is equal to 2 plus 2 root 2. Okay. So A is either equal to 2 plus 2 root 2 times positive root 2 minus 1, or it's equal to 2 plus 2 root 2 times negative root 2 minus 1. You said one of the solutions is A is 2? Is that really true here? What's that?
Wait.
2 root 2 minus 2. Oh, Mistral, you ever Mistral, what was your resistivity question? Oh, I see yours. Oh, sorry. Yes, I do see yours. Okay. 2 root 2 minus 2. Let's see. 2 root 2. 2 root 2 minus 2 plus 4 minus 2 root 2. Okay, cool. This cancels. So you just get 2. Cool. Otherwise, it's negative 2 root 2 minus 2 minus 4 minus 2 root 2. Yeah. So it's negative 6 minus 4 root 2. Nice.
Nice.
Yeah, cool. Okay. So is that the two answers? Could it be 2 and it could also be this? I could plug it back in, I guess. I just don't want to. Okay. Cool. I'm going to count it. I think we did it. Yes, correct solution. Yay.
That's dope.
Beans.
Beans.
You know what I've never had? Collard
What?
greens.
Collard greens are fucking dope.
That's dope.
I love collard greens. Big fan of collard greens.
So this might sound like an odd question because it's like if you ask someone what is chicken, what is collard greens?
Collard greens is it's kind of like a spicy spinach. Like it's like a peppery spinach. Yeah, they're really good to like soak in like chicken stock and stuff. They take on, they're like mushrooms. You know, like mushrooms take on like meaty flavors if they're like soaked in them. Collard greens.
But I don't like kidney beans.
Oh, you don't like kidney beans? Yeah, those are kind of. You mean like black-eyed peas? Or are you talking about the red ones?
No, kidney beans. Yeah, they look like kidneys.
Yeah, yeah. So there's a tradition in the South where you eat collard greens and black-eyed peas, and it's supposed to be like good luck for like the next 20 years or something. They're so good. Oh, I'm so hungry right now. I want some collard greens. Fuck. Ethan, you around? Let's see your question, and then I got a couple more circuit questions I gotta do. Mistral, I will ping you. Don't worry.
But yeah, there was a question I had about that previous one.
Yeah, what's up about this one?
When you had the negative square root of 2, isn't that like 2i or imaginary then?
Oh, yeah, no,
Which
but
would
it's the no. If you have the square root of -2, that's equal to 2. That's equal to I square root of 2. But negative square root of 2, that's okay.
That could just be negative 1.4142.
Yeah.
Like
You can't have the negative underneath the square root. That's the only rule.
I don't know.
Okay, cool. This is a very nice kinematics question.
This is like
So-
projectile motion.
It is projectile
I
motion.
just
It really is.
But yeah, when is this
What's
like
up?
I'm not being impatient, but like does the kudu challenge like start?
Very soon. I need to still deal with like grading my exams for my physics class, but it'll start this week. Just maybe by Thursday, I think, because that'll be the day before my final that I have to give. Let me see. I appreciate you guys see it and everything, but we'll do soon. Okay, here. We got a velocity, right? 12 meters per second, 50 degrees. First thing you got to do is you got to break that into components. Yeah,
What do you
grading
mean by
exams.
breaking it into components?
Well, so this is the diagonal velocity, so I need like up, down, and left, right components of it.
Alright.
So this ends up equaling 12 cosine of 50 degrees. And if that's 12 cosine of 50 degrees, what is Vy going to be? Thanks for the follow,
12
Scylla. 12 sine of 50.
50.
Yeah, good. 12 sine of 50 degrees.
You might cosine our inverse, right?
Correct. Yeah, they're complementary or 90 degrees orthogonal, whatever they want to call it. Okay. How long will the ball stay in the air? That's cool. So, the ball staying in the air only really depends on like up-down motion, right? Because that's what being in the air is. Like, I don't really care how far left-right you're going. I just care how far like up-down you're going for being in the air. Okay. So, in the air, look at y. Look at the y direction. Okay. And what we can do there's a couple ways to do it, but you can have your kinematics equations, which is good for projectile motion. This one.
And also, I saw kinematics in the Code of Fate. Is that going?
Yes.
Do I have to use the same formulas?
Yes, exactly. Yeah. If you want to do the physics challenge, yeah, you got to do some kinematics. Yeah.
I mean, I did learn that from Noisers. In fact, where is he? I haven't seen him in such a long time.
We don't know where Noise is. I think he was at some festival like banging gypsies like later, wasn't he? Where's Noise?
Speaking of someone else, it's like I remember this guy from like 2 years ago. Where is that so-called infamous teacup at?
Oh, Teacup. Yeah, I saw him a couple weeks ago on the stream. He might be taking some college classes and needs some help. He's doing okay for now. He'll be back.
All right then.
Okay, so in the air, I only care about stuff in the y direction, and I want to figure out the time. So I think what I'm gonna do is I'm gonna use this equation. So this delta x, this is like y final minus y initial is equal to your initial velocity in the y direction times t, and then plus 1/2 at squared. Okay. Now, if I want to know how long something stays in the air, that means my final y height and my initial y height are both 0.
Wait, if something is in the air, what you say?
I want to know how long something stays in the air. So when it starts, right, it's on the ground. And then when it finishes, it's also on the ground. So that's why like initial height and final height are both 0.
All right then.
Cool. Okay, so then I have 0 is equal to, so V naught in the y direction, that's this. So 12 sine of 50 degrees. times
2
t,
degrees.
and then
Times
plus 1/2. What's the acceleration of something in the air for the y direction?
Is that 9.81 meters per
Negative
second?
9.8. Negative 9.8.
Negative. Wait, when did that become negative? What?
Because it's pointing down.
Oh, right. Yeah.
T squared. Cool. So then all you got to do here is solve for t.
Yeah. Sorry
So-
about that. I'm just all asleep.
12 sine of 50. It's like 9.19.
9.19.
And then that's going to be minus 4.9 t squared. So you can then factor a t out. You see how there's a t in both these things?
Mm-hmm.
So you get 0 is equal to t. And then it's 9.19 minus 4.9 t.
Wait. Hold on. So you take just t, right? Not t squared.
No, because I can't take t squared out of this as well. So here you should see there's two solutions, right? There's like t equals 0. This is called a trivial solution because it doesn't really make much sense for the thing to be in the air for 0 seconds. But technically, that is a time when it starts at 0 and ends at 0. Technically 0 amount of time. So all you got to do is solve for this one. And that gets you that t is equal to 1.88 seconds. And so this is the non-trivial solution. T equals 0 is the launch time. Exactly correct, Femvox. Yeah, you're so right.
Oh, but like for real, wait. Could you? Okay. Wait. How did you solve it? Because I'm still seeing the t there.
So right here, I just set this one equal to 0, right? So in order for these two things multiplying by each other to equal 0, I either need this to equal 0, or I need this to equal 0.
Alright.
Right? And then you can just solve for t here. Because this is the same thing as 9.19 is equal to 4.9 t.
Oh, and then you just divide both sides.
Divide both sides, you got it.
My man.
Yes.
Alright.
How far will the ball go before hitting the ground? Okay. Well, we already know how long it spends in the air, right? So to know how far it goes, you just need to look in the x direction, okay? So if something spends 1.8 seconds in the air, and it's in the x direction going with a certain velocity, we know that in the x direction, you're going to get that. So delta x is going to just equal to Vx times t. And so this will be 12 cosine of 50 degrees
Times t.
times the amount of time it's in
That's
the air,
all.
which is 1.88.
1.88 here.
Yeah.
You solve for that, and then you
Yeah,
just
solve
get your
for it.
answer for b.
Yeah. And that gets you 14.5. So 14.5 meters.
14.5.
That's how far the thing
45.
travels in the x direction before it hits the ground.
Oh.
Maximum height of the
And
ball.
But
So
like
there's a
potential
there's a
energy?
no, not there's no potential energy in this one. There's kind of a cheat for this. So if something starts on the ground and ends on the ground, then its maximum height is the halfway time. It's like halfway in between these.
Yeah.
The real
So,
way is to figure
how
out when the y velocity is 0, but this is like a little cheat. So t1/2 is equal to 1.88 divided by
Why is
2.
1/2 all the way down there?
What?
Why is 1/2 all the way down there? But
This is a subscript. It just means like the halftime.
alright.
So y final equals y initial, and then plus
Oh.
v naught y times t minus 4.9 t squared. But now I'm gonna plug in the halftime.
half time. Alright.
Yeah. So that's going to be 12 sine
V-
50.
Alright. 12 sine 50 again. Times 1.88 divided by 2, right?
Good. Minus 4.9 times 1.88 over 2 squared. See what we get.
All right.
12 sine 50.
So what is 1.88 divided by 2 anyways?
The halftime.
No, I mean like what's the actual answer? Like what's the actual like
I'm getting it right now.
halftime there?
I'm getting it.
Alright.
Well, it's like 0.9
8
seconds.
All right then.
Sick. You get a maximum height of 4.3 meters.
All right
You're
then.
done. Nice. That's a good project. It's a good projectile motion question. Projectile motion, GG's. Yo, what's this thing? Nick's showing me his car he made. What is this? You've spent 6 hours on this? Is this what people do? They time themselves how long it takes them to do Lego stuff?
I think it said how long it takes on the box.
It probably does. Oh, it says 24 hours race car. Well, I think that's just like a Le Mans race car. I don't think it says like how long it takes. That's cool, man. Technics are dope. Oh, that's cool. It has a gear system in it. Wow, that's really cool. Wait, does this have an engine in it? Oh, it might. That's actually really cool. Okay, good job, Ethan.
Thanks so. But that to go.
You're welcome.
Yeah,
What's up, dude?
So there's a couple of things. I'll be back at working tomorrow, so I won't
Okay.
even be able to ask a question for tomorrow unless I would ask to use the restroom. But I think I might get in trouble for
Yeah,
that.
let's ask
Right.
the rest. Don't sneak off in the bathroom for our stream, dude. It's okay.
Nah, but for real though, I'll just be lurking in the chat.
That's cool,
Try to
dude.
get that 1,100 SCP. And also since we're playing Fortnite this weekend,
We're gonna play Fortnite this weekend.
I downloaded Fortnite on my computer because my Xbox is just off right now. But let me tell you, my PC, like this same computer I'm using, is absolute trash. Like if I try to boot up a game, it just it says the game's crash.
Oh no, that's not good.
I try to figure out how to fix the thing, but it just keeps doing the same thing. I don't know what to do. Yeah, it tells me how to like get some Intel thing or whatever.
Intel thing. Yeah, maybe you got to put the Xbox in the oven.
Xbox in the other end, then we'll fry the whole thing.
Yeah, sometimes like the solder like joints go cold and you have to like remelt them. So one of the solutions is to put it in the oven.
That was the 360.
That was the 360, the Red Ring of Death. Yeah, you remember that? Like people were like, yeah, put your fucking Xbox in the oven.
I have X/S version.
Yeah. I don't know. Maybe ask ChatGPT. ChatGPT could probably diagnose it for you, honestly. Pretty smart.
Yeah. Nah, I know the solution, but it's just that my dad wants to get offline games, and that's why he has it off for now.
Oh, okay.
Like a bug. Yeah, and also I was checking the SC announcements.
Yes.
Sorry, the leaderboard. I'm literally in top 6 right now.
You're getting up there, dude. Don't worry. There's also
Hey,
like a talent show. There's a lot of stuff.
I don't know if I can compete in that.
Oh, come up with a cool talent, dude. Think what you did last year.
Okay. I never did anything last year for a talent show.
You didn't do anything with a talent show? Oh, you should.
No, I never participated in a talent show any at all.
Oh, okay. Well, compete in
either
this one's.
Yeah, I'm gonna compete as well.
Yeah,
I'm gonna do I'll do an art video just to be sitting there randomly saying the N-word.
I get us kicked off of Twitch.
Completely out of context as well.
Yeah.
It's like I'm sitting here drinking my nice cup of hot.
God damn it. Oh.
Well, thanks for the
Jeez.
help, but
You're welcome, dude. Okay. Current density, dude. What is this bitch of a problem, dude? What? Mistral, did I really assign this to you? I'm sorry.
It was the best of times. It was the worst of.
Is that the thing where it's... Dude, you know what's the best one? And I actually know the guy that did this. Have you heard of, like, the Book of Yea? Where the guy replaced, like, every instance of the word God, I think, in the Bible with Kanye West.
Just Kanye West.
Yeah. It's actually pretty
Kanye
brilliant.
West said under the kind of
Yeah, it's called the Book of Ye. Actually, you guys remember him? His name's Sawyer. He used to have like some cool little AI thing that we were testing here on the stream at some point. Yeah, he's a funny guy.
Dark's like, that's what I'm supposed to do.
Yeah. Don't do that, Nick, please. Please, Nick. Mistral says, yeah, you assigned it for sure. My bad. Okay, I'm like really tired at this point. Current density is I over A, I think, right? I can remember like all the things. So J is equal to like I over A, which is also equal to, I think, sigma E, which is equal to, oh fuck me, 1 over rho E. I think that's what it is. Oh, it was due today. Oh, oopsies. No office hours since Wednesday. Yeah. Yeah. Okay. I think this is how you do it.
What the fuck is Hostler University?
Hostler University? Hustler University?
Hostler.
I'm pretty sure that's what Andrew Tate like advertises. Hustler University. It's a scam though. You shouldn't do it. Oh, okay. We're kind of close here. Okay, I'm pretty sure J is equal to 1 over rho E. See, I got a row underneath here. Uh-huh. Okay. And then the electric field. Yeah, okay. So electric field is equal to, for a point charge, right? Electric field for a point charge. Wait, and what is R? Oh, okay. Yeah. Okay. Electric field at some location R is equal to 1 over 4 pi epsilon naught. And then it's Q over R squared in the R hat direction, right? Because it's technically a vector. So the other way to write this in like vector form is to say 1 over 4 pi epsilon naught Q, and then you say over the magnitude R to the third, and then you say R vector. The reason for this is that R vector is equal to the magnitude of R in the R hat direction, because this is a unit vector of length 1. Okay? And then this is the magnitude. It doesn't. You're right. And that's why they're doing R minus D. Yeah. So D is the vector. I think they're assuming. I think maybe they're assuming that the origin is at A. This is not. I didn't write this question, but I think what they're assuming here is this is like the origin. So if you're located some distance R away, okay, the electric field due to that point charge would be this. So this is the electric field. So here, this is like of the A one. Let's say like EA is equal to this, okay? Then for the B charge, EB, okay? Well, that's going to be a negative Q. So I'm going to say negative Q 1 over 4 pi epsilon naught. But now I got to be kind of clever with the R here. So if R is pointing here, then, and then again, this is vector D. Then this, which is like RB, is equal to sorry, it's equal to r minus d, I think. Yeah. This is equal to vector d minus vector ra. Okay. Uh-huh. Okay. So that's why this is here. Right. Well, for the multiple choice here, right? It can't be this one. It can't be this one. Because what? You can't have the electric fields be going as, like, different things. Like, this is r squared. This is 1 over r. Yeah. You want this for sure. Because this over this gets you 1 over r squared. This gets you 1 over r. This gets you 1 over r. This gets you 1 over r squared. And this is not 1 over r. And then this gets you 1 over r. And then this is not 1 over r. So this is the only one that really makes sense. But why that is... Yes, okay. So, if I were to write this, then vector d plus vector rb is equal to vector ra. Yeah, that's the only one that looks like 1 over r squared, right? Yeah, okay. So, rb is equal to ra minus d. Okay. So, when you do this one, okay, because this is supposed to be ra, but RA, we're saying, is the same thing as R. Because we're going to say that R is measured from the origin of A. Then this Mistral, this is going to be Q. Well, we're going to put the minus Q. So that's going to be RA minus D. Whatever, to the third RA minus D as a vector. But then the minus sign is going to switch this to D minus R instead of R minus D. So this flips with this. And then you get Q vector D minus RA all over RA minus D magnitude cubed. Yeah. And in this case, RA is the same thing as R. Because we're measuring the electric field from the origin, from that point, from point A. And again, current density is just 1 over rho times the electric field. So that's why you have 1 over rho here, and then this all this other part here. That's the electric field. Yeah, it's kind of sneaky for them to just say like. Current density, like what they're basically just asking what's the electric field, and then put you slap a 1 over rho on it. Oh, does that make sense, Mistral? You did that whole reading group with Don, but a lot of this didn't stick in my head. Yeah, a lot of it's kind of like tricky. Also, like Don does math. Don doesn't do physics. So I think that was interesting that, I mean, I praise him for like leading an E&M physics course, but that would be like me trying to lead like a discrete math course. Like, cool, we'd get to learn alongside me, but I have no fucking clue what discrete math is. Yeah, you've never used the vector form before? Yeah, I agree. It's kind of tricky. But it's good to get used to like what this is, because when you take upper division E&M, this is everything. It's all vector form. I think we try to like keep things kind of nice so far because this is an intro course, but when you get into upper division, you have to do things in vectors. Okay, nice. I got like 10 minutes. G2 is what's his face here? Let me see. He had a chat somewhere. One of these chats I was talking to him.
While you're doing that, here's a announcement for everybody in chat that's listening.
Yeah.
Fatboy Praise You by Fatboy Slim.
I do love
You're welcome.
Praise You by Five. I actually have that on vinyl. I have that song on vinyl.
Very nice.
Mr. King Awesome. Oh, here, let me tag Mr. King Awesome if he's in. Yeah, I do have it. It's You've Come a Long Way, Baby, right?
Wait, the album?
Yeah. Isn't it? Is it You've Come...
The song's called Praise You.
Yes, but it's on the it's on this album.
Yeah.
Yeah. You've Come a Long Way, Baby. I have this album.
Brilliant album.
It's a beautiful album. I love Fatboy Slim. Fatboy Slim's fucking great. Let me see. Fedekai had a question. I wanted to ask if Tau is specifically RC or does it change depending on the setup of the circuit? For a simple Fedekai, for a simple resistor capacitor in series circuit, it is just one over RC. I think if things start to get weird, if you got like parallel shit going on, and that has to do with like the derivation we came up with, right? Which was, do I still have it up? Yeah, this was it. This was the derivation, right? So remember that 1 over RC kind of came from like this and this just being in series. So it's not strictly going to be 1 over RC if it's not in series.
There we go.
Is this a song?
This is the song.
I tried to click on it, dude. Yes, dude. This is a great song. That's absolutely great. Dun, 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 dun. We've come a long, long way. Oh, Mr. King's awesome here. Nice. You're good. Oh, one second to stop the song. I got to praise you like I should. Yeah, it's a great song. Great album.
Where's he from? Norman Cook. Where's he from?
Oh, he's from Brighton.
Brighton. Oh, yeah, that's it.
Because he has a song called "You're from Brighton" or something, right? Sorry, I'm trying to figure out where my windows are.
See, that's so weird. There's the way people from the US pronounce things. You overdo it in some instances and underdo it in others.
Dude, I overdo it all the time.
Especially when it comes to place names. It's like you say Brighton, like really, really hard.
Yeah.
But whenever something's T-O-N, which is a contraction of town, just so you know. We always kind of...
Jamestown?
Kingston, Brighton, Huntington. Although that's slightly harder.
Let me see here. Okay, in the circuit shown, switch S1 has been... This is an AC circuit, RLC, unfortunately, I think. No, it's DC. So that the current reads a steady 3.5 amps. Suddenly, switch 2 is closed, and switch 1 is opened at the same instant. What is the maximum charge that the capacitor will receive? Ugh, sorry.
Is that not a trick question? If you close switch 2...
Well, this has to do with inductors. Yeah, no. So you're saying you close switch 1, and so you're just going to have current running this way. You're initially actually not going to have much current running at all. Inductors resist changes in current. So when you first hit this switch, this thing will try to provide a bunch of back voltage or like back current to try to stop this. It's an inductor. But if switch 1 is closed for a long enough time, then eventually this is there is a steady state current. Oh, interesting. Okay, no, all right. I think I know where this is going. And okay, suddenly switch 2 is closed and switch 1 is opened. So now you just have an inductor and a capacitor. What is the maximum charge? Ooh, okay. Fuck. Oh, I know what'll happen. Okay. So this inductor is suddenly gonna notice that it no longer has... What's up? It no longer has current. And so, because it no longer has current flowing, it's gonna provide a back voltage of LDIDT. Right? This will be like the voltage of the inductor. And then that voltage will charge the capacitor. Okay. And then eventually the change in current will go down to 0, so then this... Oh, you know, I think this is a conservation of energy question. Mr. King Awesome. I think the energy here has to equal the energy here. Eventually. I think it'll actually, like, it'll oscillate back and forth. Because it'll charge the capacitor, and then the capacitor will try to discharge itself. Yeah, this thing will ring. Okay, energy of an inductor is 1/2 Li squared. And this is equal to 1/2 CV squared. These cancel. Yeah, no resistor in the loop means it's a tank. Sorry, what does a tank mean?
In the sense of a water tank, I would imagine.
Yeah, what is a tank? Sorry, what? Confused what the tank means.
In the sense of a water tank, you fill a water tank. Well, because
wouldn't it try to discharge itself, though? Would it not?
The current can't go anywhere because there's no open circuit to the battery.
Oh, you're right. You're right. Well, I mean, technically, the inductor is an open circuit. Or a closed circuit, sorry.
Right, but it could only... the electricity can only flow from the inductor to the capacitor and then back to the inductor again.
Oh, I see. Okay, yeah, wait. LC circuit. A resonant circuit or a tank circuit.
So that is an actual thing. I just thought he meant filling it up like a water tank.
I think it oscillates, dude. Yeah, look, it oscillates. So look, it charges, and then it discharges, and then it charges, and then it discharges. Because the inductor is always trying to fight the current. Oh, that's cool. Okay. Anyways, I think it's just 1/2 Li squared equals 1/2 CV squared. And then so Q equals VC. So C equals Q over V. Ugh. So Q. Well, I already have the capacitance. Sorry. V equals Q over C. So it's CQ squared, right? No, Q squared over C. I'm taking ECE engineering. Any advice? I don't know. I haven't taken that exactly, but it sounds like you probably have like a fun like group project or something you do. Okay. I think this is how you solve for it, and then just solve for Q. Sorry, I gotta run in I literally have a meeting with the professor in like 5 minutes, so I don't know how much time. What's the current in the inductor? Well, when there's maximum charge, or sorry, you mean, what's the current in the inductor? Is this asking when you have maximum charge? Or when I think when you flip the switch, this is just going to be the same 3.5 amps. Yeah. But anyway, solve for this. I think you get it.
That's dope.
Does that make sense, Mr. King? Also, yeah, look up this. This is kind of the cool animation of like what's happening. It's called an LC circuit, which I guess is a tank. But cool. Okay. Nice. That visual helps. Thank you. Yeah. Great. I'm glad I could, Mr. King. Yeah, when the cap is fully charged, current will be 0. I agree with that. Yeah, I agree. When this charges, there's no current. And then as it discharges, now you have current through the inductor, which means you have back voltage, which is that LDIDT. Yeah. It oscillates. Okay, cool. Let's end this one. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate all the questions. Our next stream is tomorrow. That's going to be at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Come on by. Get help with your math, science, all that fun stuff. Circuits, you got in late. Yeah, we'll come by tomorrow, dude. Yeah, if you're not already following us, go follow us on all the things. Twitch, YouTube. Join our Discord if you want to get more help with stuff. Let's go raid somebody. Who do we got? Everyone's just playing video games today. What? Zacap is doing something. Oh, I guess you know what? High Potential's on. He's a fun guy. This guy's funny. Yeah, go talk to High Potential. He's a crazy mad scientist. Go ask him what he's doing. Okay. I got in late. Okay, thank you, Actual Education's dad. Until then, we will see you guys tomorrow. Enjoy your Monday. Peace.